All right, people. I believe everybody is doing great, nice, and absolutely fine. So, welcome to this beautiful session. Welcome to this beautiful session. So, in the today's session, we are going to basically start the new chapter that is what we call the kinematics. Okay. And everything will be from the scratch. When it comes to the NEET examination, this is one of the most important chapters and we consider it among the high weightage chapters. Okay, you can expect 2 to 3 questions from this particular chapter in your NEET examination, that's for sure. So my dear friends, let me know in the chats if everything is going great. Okay, everyone means everyone. And most importantly, if you have not liked this session yet, I would want you guys to hit the like button as soon as possible, because liking this session is extremely mandatory, and afterwards we are going to start our journey. Okay, so let's start this particular session, guys. Okay, let's take a look over here. See, when it comes to the kinematics, we say the entire kinematics we have over here, there isn't much in this one. We have velocity, average velocity, acceleration, okay, and we have got equations of motion and some graphs that will be in the kinematics 1D. Now guys, listen to me very carefully. Listen to me very carefully. Since I told you, if you have not studied the kinematics before this, and if you are learning the kinematics for the first time, I'm 100% sure you would be able to understand each and every single point. That's my guarantee. Okay, the first topic. Now, see. Let me just tell you over here, my dear friends. When it comes to the kinematics, understand very carefully. When it comes to the kinematics, we say, what is this kinematics all about? Okay, what is this kinematics all about? Guys, let's suppose I have got a car exactly over here. I would want you guys to understand each and every single thing very carefully. Just a second, I'll fix up the settings of the camera. Yeah, cool. Fine now. Yeah. So guys, when it comes to the kinematics, let's suppose I have got a car exactly over here. And this car is, let's suppose, in motion. It is in motion. Okay. Means this car is changing its position with time. As it is moving forward, the car is in motion. That's what I'm trying to say. And my dear friends, when the car is in motion, what do we actually talk about over here? We say, sir, how much is the displacement of the car? How much is the distance covered by the car? How much is the velocity of the car? How much is the speed of the car? So all of these things we talk about a car in motion, okay? So these are the terms related to the motion. So whenever we discuss about displacement, distance, velocity, so means we are talking about the kinematics. So in kinematics, we basically talk about motion. It is simply study of motion. It is study of motion without knowing the cause. Okay, cause means if the car is moving, sir, why is it moving? Is there any force which is acting on the car? So that we study in Newton's laws of motion. So simply remember, when it comes to the kinematics, we talk about motion. And what do we study in motion? We say, sir, displacement of the car. If the car is in motion, how much displacement it will cover, how much distance it will cover. We talk about the velocity, how fast the car is moving, how fast the velocity is changing. So all of these things we discuss in the kinematics. Guys, please tell me in the chats, is everything crystal and clear till over here? And I would want you guys to basically hit the like button, because liking this session is extremely mandatory. Okay? Liking this session is extremely mandatory. Everyone means everyone. So, now guys, understand very carefully what I am going to discuss over here. The very first topic, we'll be finishing this chapter in only 3 parts. The very first topic that we need to understand over here is, see guys, the first thing we need to understand over here is, that is frame of reference. Frame of a reference. Frame of reference. Guys, understand very carefully. Let's suppose I say this is the car over here. Guys, the first topic that we are understanding over here is frame of reference. Let's suppose we have got a car over here. I am saying from this point, this car is, we say, sir, 10 meters away. From this point A, we say, sir, this car is 10 meters away. Okay. I'm saying that, let's suppose we have got a point B over here. I'm saying that from the point B, this car is, let's suppose, 15 meters away. Sir, what is this point? We say, if we consider this as a frame of reference, then we say this car is, we say, 10 meters away. I hope you are getting me. And when we talk about this point, when we consider this as a frame of reference, so we say this car is 15 meters away. So frame of reference means with respect to what we are talking about. With respect to what we are talking about. It means with respect to what we are talking about. Okay. Like here, we say with respect to this point A, the car is at 10 meters. The displacement of the car is 10 meters. I say with respect to the point B, the displacement of the car is 15 meters. So here this is frame of reference, and in this case this is frame of reference. I hope this is clear. Guys, tell me, frame of reference can be anything. You can consider there is a tree. Sir, the distance between me and that tree is, we say, 10 meters. So in this case, that tree is frame of reference. Sir, can a frame of reference be a table? Yes. If I say the distance between me and that table is 15 meters, means that table will be in that case frame of reference. Guys, tell me in the chats, give me the signal. Is this crystalline clear? Is this crystalline clear? Everyone means everyone. And hit the like button if you have not liked the session, and I would want you guys to hit the like button as soon as possible. Is this clear till over here? Is this clear till over here? Okay. Now, next. What we need to understand is, that is what we call observer. That is what we call observer. Sir, what is this observer all about? Guys, see. Observer means who is observing the situation. Who is observing the situation? See guys, let's suppose I have got a car. This is a truck, exactly, bus. Okay. And this bus is in motion. Understand very carefully, my dear friends. This bus is in motion. And in this bus, we have kept the person A, and there is one more person, it is B. In this bus, we have got two people. First one is A and another one is B. And there is another person which is exactly on the ground, which is at rest over here, and its name is C. Now, when I ask this person B, I ask the question to this person B, tell me, is A in motion or at rest? Guys, see, bus is in motion, so means A is in motion. So when I ask this person B, bro, tell me, is this A at rest or A is in motion? Person B is saying, I can speak to the person A. He is sitting beside me, okay, on my side. I can speak to him. I can talk to him, I can share everything I want with him. So he is completely at rest. According to the person B, A is at rest. Because both are sitting in the same car. We say according to, I say according to B, we say A is at rest. A is at rest. And now, my dear friends, listen to me very carefully. When I ask the person C, could you please tell me, is this A person at rest or is he is in motion? Person C is saying, car is in motion. So obviously, the person sitting inside the car is also in motion. So we say, I'll write over here, according to C, I say A is in motion. A is in motion. So means, my dear friends, here, we say, when we consider this as a observer, when this is observing the situation, in that case, we say A is in motion. And when B is observing the situation, in that case, we say A is at rest. So it depends who you are considering as an observer. When B is observer, in that case, A is at rest. When C is observer, we say in that case A is in motion. So A is at rest as well as in motion. It depends with respect to what you are talking about. If you are considering A as observer, B as observer, then rest, C as observer, then motion. Okay. Okay. Yes. Yes. Now, guys, I hope this is clear till over here. I hope this is clear till over here. Now, guys, one more important point I just want to clear over here. I say sometimes the observer can be also the frame of reference. Sometimes the observer can also be the frame of reference. Like I say if there is a person over here, this is person A. And there is an object which is placed, I say this object is placed at, we say, sir, 10 meters. This object is placed at 10 meters. Right now, if a person is saying that, hey bro, this object, this box is at 10 meters from me. So in that case, we say here, A is observing the situation, and with respect to the A, the distance is 10 meters. So here we say A is the observer, A is the frame of reference. And let's suppose let's suppose here, if I say the same person A, and the object is, let's suppose, at 15 meters. The object is at 15 meters. And there is another person over here, C. This person C is saying that with respect to the A, we say object is at 15 meters. In this case, I say C is the observer. Why? Because C is observing the situation. And we say A is the frame of reference. A is the frame of a reference. A is the frame of reference. Here, C is the observer and A is the frame of reference. And in this case, we say when A is saying, with respect to me, object is at 10 meters, means here, A is the frame of reference as well as A is the observer. Guys, please tell me in the chats if this is clear. Please, guys. Everyone means everyone. Guys, I need the signal from every single student. Okay? I need the signal from every single student. Whosoever is watching, I need the signal that if this is crystal and clear. Let me know in the chats. Great, great, great. Great. Now guys, understand one more thing. Observer is done, definition of kinematics is done, frame of reference is done. Let's talk about now the types of motion. Types of motion. Let's talk about the types of motion. Okay. Let's now talk about the types of motion. Guys, see, I'll make you understand what are the different types of motion. The first one is, that's what we call the one-dimensional motion. The first one is what we call the one-dimensional motion. One-dimensional motion. Sir, what is one-dimensional motion? Understand very carefully. Understand very carefully. Let's suppose, my dear friends, I have got an object exactly over here. There is a car which I have in front of me. And this car is, let's suppose, moving in the forward direction. Something like this. Something like this. It is moving horizontally in a straight line. We say, let's suppose if I make the graph over here. This is, we say, y-axis, and this is, we say, x-axis. I'm saying that this car is basically moving in the horizontal direction, something like this. I am asking you, how many coordinates of the car are changing over here? Let's suppose when the car reached this point, we say here, value of x is, let's suppose, 4. Here, value of x is, let's suppose, 1. When the car reaches over here, value of x is, let's suppose, 6. So, car is moving along x-axis only. Car is changing only its one coordinate, x is equal to 1, x is equal to 2, x is equal to 3. Sir, is the car going up also? No. We say y coordinate of the car is same. It is same. It is not changing. But here x coordinate of the car is changing. So means this is what we call the one-dimensional motion. That motion in which only one dimension of the car is changing is called one-dimensional motion. Sir, what about this? What about this? What about this? Let's suppose there is an object which falls something like this. An object, it falls on the ground, it's a free fall. Sir, is it one-dimensional or two-dimensional? We say it is one-dimensional. Why? Because here only one of the coordinates of the ball are changing. Here, let's suppose value of y is, we say, sir, y is equal to 5. Then y is equal to 2. Then y is equal to 3. Then y is equal to 1 and so on. So only y coordinate of the ball is changing, decreasing. Here, initially 5, 4, 3, 2, 1, something like that. Okay. And we say in this case only x coordinate is changing. So I can write over here when only one of the coordinates of an object, when only one of the coordinates of an object are changing, it is called 1D motion. It is called 1D motion. Okay. So it is basically motion along a straight line. It is basically motion along a straight line. A car is moving in the horizontal direction. We say it is one-dimensional motion. A ball is falling vertically downwards. We say it is also one-dimensional motion. Here y coordinate is changing. We say here only x coordinate is changing. We say here only y coordinate is changing. Here only x is changing. Here only x is changing. Here only y coordinate is changing. Okay. Great. Next we have, my dear friends, that is what we call the two-dimensional motion. Two-dimensional motion. Next is what we call the two-dimensional motion. Guys, understand very carefully. Let's suppose you have basically, this is y-axis and this is x-axis. Let's suppose you have thrown an object something like this, like projectile motion. You take a stone and you throw it in the air and it basically goes from ground and falls onto the ground. So we have, let's suppose, launched a stone from the ground and it falls onto the ground. So we say this is the two-dimensional motion. Why? Because here two of the coordinates of the body are changing. Like, let's suppose when the object was over here in the air, when the object is in the air. Okay. And in this particular case, we say, sir, in X, body has covered this much of displacement. This is the horizontal displacement of the object when the object is exactly over here, that is X. And how high it has gone, this is the vertical displacement, that is Y. Here, object is moving forward as well as object is moving upward at the same time. So that's why we call it the two-dimensional motion. When two of the coordinates of the body are changing. When the object is over here, this is the height of the object and this is the horizontal distance of the object. And I can write in this particular case, when two of the coordinates are changing. When two of the coordinates are changing, it is called, we say, two-dimensional motion. We say it is called two-dimensional motion, as simple as that. Okay. Okay. Now guys, then we have three-dimensional motion. Three-dimensional motion. Then we have three-dimensional motion. What is a three-dimensional motion? Guys, understand very carefully. I would want you guys to understand. We say when three of the coordinates of the body are changing, in that particular case, that is what we call the three-dimensional motion. Like, this is the x-axis, this is the y-axis, and this is the z-axis. If an object is going something like this, it is moving forward in x, it is going up also, and it is coming out also at the same time. So we say it is moving in three coordinates. So we say this is what we call the three-dimensional motion. So I write over here, when all the three coordinates, when all the three coordinates, example of this is basically projectile motion. And also circular motion. So we say when all the three coordinates, this projectile motion is the example of, we say, two-dimensional motion. We say when all the three coordinates of an object are changing, it is called, we say, three-dimensional motion. Okay. Example. Motion of a butterfly in the garden. Okay, if you throw the stone in air, that is the two-dimensional motion. Motion of a butterfly in the garden. What is the motion of the butterfly? Something like this. It goes forward in x. It goes high also. It goes upwards also. It comes out also. It is moving in all the three coordinates, all the three axes. So we say example. Motion of a butterfly Motion of a butterfly in a garden. Guys, hit the like button if you have not liked the session yet. I would want you guys to hit the like button as soon as possible. That is mandatory. Everyone means everyone. Is this crystalline clear? Is this crystalline clear? Let me know in the chats. Is this crystalline clear? Let me know in the chats. Everybody out there. Is this crystalline clear? Great, 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 great. I hope you guys are loving the session, okay? I hope you guys are loving the session. I'll make you understand each and every single point. That is my responsibility. Okay? So you don't have to worry about anything. Okay? Great, great. Now guys, let's move on to the next topic. That is what we call the position. That is what we call the position. Sir, what does position actually mean? Position simply means the location of an object. Position simply means the location of an object. Let's suppose I say there is a person over here. I say there is a person over here. This person is A. And I say from this person, there is an object which is placed, or there is a car which is at, we say, sir, 10 meters from this person. Now, I can say in this particular case, position of the car is at, we say x is equal to 10 meters. Position of the car is at x is equal to 10 meters, and with respect to, we say person A, with respect to person A, because mentioning the frame of reference is extremely mandatory. You cannot say the position of the car is 10 meters because that is invalid, that is wrong. With respect to what? With respect to that person, because from that person till me, the distance is 100 meters. So that's why I say with respect to A, the position of the car is 10 meters. So what is position? So I can write simply position. It is the location. It is the location. It is the location of an object. It is the location of an object with respect to the frame of reference. With respect to the frame of reference. Okay, so it is the position of an object with respect to the frame of reference. Like position of this object is at x is equal 10 meters with respect to the A. A will be over here, the frame of reference. Okay, okay, yes. Now my dear friends, if I say over here, if the position of an object is not changing with respect to time. If the position of an object is not changing with respect to time, means initially the object was over here, finally the object is over here also, then we say object is said to be at rest. Then object is said to be at rest. then in that case, object is said to be at rest. In that case, object is said to be at rest. And if the position of an object is changing with respect to time, in that case, we say object is in motion. In that case, we say object is in motion. I hope both of these points are clear. I hope both of these points are clear. Okay. Let's move on to the next one. Let's move on to the next one. Let's move on to the next one. See, guys. Enough. Is this clear? Please tell me in the chats. Is this clear? Please tell me in the chats. Everyone means everyone. Okay. Now, let's talk about displacement. Let's talk about displacement, and before that, let's talk about distance. Distance and from the either side over here, I'll write that is displacement. Here I'll write displacement and here I'll write distance. Guys, see. Let's suppose you live at this particular point. This is what we call A. This is your house and you live at this particular point A. And I say this is your friend's house, that is we say sir B. This is we say sir B. Now you have to move from A to B. You have to go from your house to your friend's house. So basically this is the road that government has made and you are basically traveling through this path and you reach the point B. Now, this path is basically a bit longer. So since if you are moving from A to B, you are covering the distance. Sir, how much distance you have covered? We say this much distance you have covered. Okay. Now, my dear friends, understand very carefully what I'm trying to say in this particular case. If I say this path is, we say, sir, a bit longer. When you reach the point B, you are saying to your friend, what if there was a road between A and B which was something like this, exactly something like this, a straight road. And this straight road will be, in that case, we say, sir, the shortest distance between A and B. Sir, this person has traveled along this path. But when they reached over here, he is discussing with his friend, what if there was one distance? What if there was one road between A and B, which was something like this, the shortest path between A and B. The shortest path between A and B. So we say, my dear friends, listen to me very carefully. This distance between A and B, which is having a proper direction, see, it is pointing towards B. It has a proper direction. This is what we call the displacement. This is what we call the displacement. So displacement is simply the shortest path between the initial point and the final point. And this was the path through which that boy actually traveled. This was the path through which that boy actually traveled. So can I say this is the actual path traveled? Guys, that boy traveled through this path and reached point B. Okay, what if I join this point A with point B with that straight line over here? This will be displacement, and this is what we call the distance. This is what we call the distance. So I can mention over here, when it comes to the distance, I say it is the actual path traveled. It is the actual path traveled. Since if you are moving from A to B, which was the actual path you traveled, sir? This one, upper one. And the shortest path between A and B is what we call the displacement. And displacement, I write over here, it is the shortest path between we say A and B. It is the shortest path between A and B, and that is what we call the displacement. And that is what we call the displacement. Can I mention over here, when it comes to the distance, I say it does not have a proper direction. Proper direction. It does not have a proper direction. Why, sir? Because see, here direction of that boy was something like this. Here direction is downwards. Here direction is downwards. Here direction is upwards. So at different points, direction is different. But when it comes to the displacement, you see here direction is this, same direction, same direction. So it is pointing towards B. So can I mention over here, when it comes to the displacement, it is that path which has a proper direction. We say it has a unique / proper direction. It has a unique / proper direction. Okay. Yes. Now, let's suppose, my dear friends, I say this is the point A, and you have traveled from point A, and you reach this point B. And in this particular case, could you please tell me what is the actual path traveled? Sir, this much is the actual path traveled over here. And I say here, actual path traveled is, let's suppose, 100 meters. And my dear friends, if you join this A and B over here with a straight path, and we say, sir, this is 10 meters. And if somebody asks you what is the distance over here, you say, sir, this will be the distance, actual path traveled, that is 100 meters. And what is the displacement? Displacement is the shortest path between initial and final point, that is, we say, sir, 10. Okay, that is, we say, sir, 10. Now, guys, when it comes to the distance, we say it can never be 0. It can never be 0. Distance can never be 0. But when it comes to the displacement, we say displacement can be 0. Displacement can be 0. Sir, what is the logic over here? Guys, see, I'll tell you. Let's suppose there is a person, he left from point A. Okay, he is moving, and he reached the point A once again. So he started from point A and he reached the point A. Okay. In this case, if I say he has covered 100 meters, this distance is 100 meters. So we say here distance is 100 meters. But when it comes to the displacement, in this case, that is 0. Why? Because the initial point and the final point is same. Displacement is basically how much he has displaced. He hasn't displaced. Why? Because he reached the same point once again. That's why we say displacement in this case is 0, but distance is 100. Distance is the actual path covered. Displacement is how much he has displaced from the actual path, from the initial point. Sir, initial point and final point are same, so we say displacement in this case is 0. So that's why I mentioned displacement can be 0, but it can never be 0. Distance can never be 0. Okay. Yes. Now, when it comes to displacement, we say distance, it can never be negative. We said distance can never be negative. But when it comes to the displacement, we say it can be negative also. It can be negative also. It can be positive also. It depends. Like my dear friends, let's suppose I say this is the origin. Okay, 0, 0. Okay, I hope you might have seen the graph, x-axis, y-axis. Okay, and if I say, sir, from here it is plus x, from here it is minus x. So this is basically the origin. If I consider the origin as frame of reference, let's suppose I am considering the origin as frame of reference. Guys, see, here value, this is 1, this is 2, this is 3, and this is, let's suppose, 4. And from left side of the origin, we say, sir, this is minus 1. we say this is minus 2, we say this is minus 3, and we say this is minus 4. Guys, understand very carefully. If I say the person is at point here, the person is over here, this is the person. Can I say in that case, with respect to the origin, this much is the displacement? With respect to the origin, let's suppose the person has started his position from origin until over here. This is the displacement. We say, sir, x is equal to, we say, sir, plus 4 meters over here. And when it comes to, if the person has started its journey from origin to here, so can I say in this case, we say, sir, displacement is what? It is minus 4. It is minus 4 over here. Displacement is minus 4. Okay. So here, displacement is plus 4. Sir, how do we actually find the displacement? Guys, wait a second, I'll tell you. Wait a second, I'll tell you. Let's suppose this is the origin. And from here, the person has traveled till this particular point. And we say here x is equal to 1, 2, 3, 4, and this is 5. And let's suppose if another car has basically traveled from origin, we say, sir, till over here. So we say this is minus 1, we say this is minus 2, we say this is minus 3, we say this is minus 4, and we say this is minus 5. Guys, understand very carefully. If the car has traveled from origin to here, we have to find the displacement. Always remember, we said displacement is final position. Always remember this formula. Displacement is final position minus initial position. Displacement is final position minus initial position. Guys, what is the final position of the car? See, this is origin. So, finally it is at 5. We say, sir, car A. This is car B. Okay, this is car B. I say here. What is the final position? That is, sir, 5 minus. We can write it something like this. That is x final minus x initial. So, what is final position here? That is 5 minus. What is initial position? Initially, it was at origin. That is 0. So, in this case, displacement will be plus 5. Let's talk about the car B. We say, sir, for car B. We say here also displacement is final position minus, we say, initial position. Finally, the car is at B. So, finally, the car is over here. That is minus 5. We say, sir, minus. Initially, it was at 0. Minus 5 minus 0 is, we say, sir, minus 5 over here. So, here displacement is negative. Here displacement is positive. So, that's what I mentioned exactly in this particular case. Displacement can be, we say, positive as well as negative. But when it comes to the distance, we say, sir, distance is always positive. So, if the car has moved from this point to this point, how much distance it has covered? That is 5 meters. You do not say minus 5. It has covered 5 meters. How much car has traveled in this case? We say, sir, 5 meters. So, that's why we say distance is always positive. Is this clear? Is this clear? Tell me in the chats, guys. Is everything crystalline clear? Let me know in the chats. I would want everybody of you to tell me in the chats. Is this crystalline clear, guys? Great, great, great. Okay, and one more point you can mention over here. We say it is a scalar quantity. Scalar quantity. What is a scalar quantity? It is that quantity which has only magnitude. It does not have the direction, or which does not follow the vector laws. Which does not follow the vector laws. And we say it is a vector quantity. Vector quantity. It is a vector quantity. Scalar quantity, and this one is a vector quantity. This one is a vector quantity. Okay. Yes, yes, yes. And if I say one more point over here, if a particle travels in a straight line, let me show you over here. If I say, let's suppose a particle basically started from this point and it reached basically this point from A to B. And we say in this particular case, this distance is, I say over here, let's suppose 10 meters. So we say a particle started from A to, we say, sir, B. In this particular case, we say, sir, displacement is equal to distance. Distance is the actual path covered. We say this is the actual path covered. Why? Because particle is moving along the straight line only. In this case, distance and displacement are exactly same. So we say both are over here 10 meters. Both are over here 10 meters. So you mention this point exactly over here. You mention this point exactly over here. We say if a particle moves along a straight line, moves along a straight line, if a particle moves along a straight line, then in that case, we say distance and displacement are equal. Distance and displacement are equal, because here the actual path covered is this, and here we say the shortest path between A and B is also this. We say, sir, if this is point A, and we say if this is point B. Okay? Yes. Okay, great. Now, let me give you a question over here. The question is something like this. Let's suppose a basic question. We'll start with a basic question. Let's suppose a car started from, we say, sir, A to B. And then car traveled from B to, we say, sir, C. This is, we say, sir, 4 meters. This is, we say, sir, 3 meters. Okay. Now, my dear friends, in this particular case, you guys are supposed to tell me, find the distance. The car has traveled from A to B, then it has moved from B to C. Find the distance and displacement covered. Find the distance and displacement covered by the car during the journey. So you guys are supposed to tell me what is the distance and displacement covered. Guys, when it comes to the distance, can we say, sir, distance is the actual path covered? Actually, it has first moved the 4 meters and then 3 meters. So when it comes to distance, we say distance in this case is simply, that is 4 meters, we say plus 3 meters, and that will be 7 meters. And when it comes to the displacement will be simply join initial and final point. That will give you the displacement. So I say, sir, displacement will be this. This is a right angular triangle and this is the hypotenuse. So can you tell me what is the value of this hypotenuse? Use PGT. Sir, that is base square plus perpendicular square. So that is under root of that is 4 square plus we say sir 3 square. So I say in this particular case displacement will be simply under root of, we say that is 4 square plus we say sir 3 square. 4 square is 16, 3 square is 9. So 16 plus 9 is 25. So it will be under root of 25 and that will be 5. Under root of 25 is 5 itself. Okay. 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 Great, great. One more thing I just want to tell you over here. Let's suppose I give you the question something like this. Let's suppose I give you the question something like this. See guys. Let's suppose I give you the question something like this. The question is a car started its journey from the garage. A car started its journey from the garage. Okay, you are having a car, you are a big doctor, okay, you are a topmost doctor of the country and you are having a car. So you started your journey in the morning, you took the car out from your garage and covered. A car started its journey from the garage and covered 6,000 kilometers. No, we do not say 6,000 kilometers. Start its journey from the garage and its meter reading, that speedometer, its meter reading was 6,000 kilometers. Its meter reading was 6,000 kilometers. And its meter reading was 6,000 kilometers. And when the car arrived back when the car arrived back and is parked in the same garage, and the car is parked in the same garage, the meter reading was we say 6,500 kilometers. The meter reading was 6,500 kilometers. And let me ask you the question over here. Find the distance and displacement covered by the car. You guys are supposed to tell me what is the distance and displacement covered by the car. Could you please tell me in the chats? What is the distance and displacement covered by the car? Everyone means everyone. Let me know in the chats, guys. What is the distance and displacement covered by the car? Tell me, guys. So a car started its journey from the garage and its meter reading was 6,000 kilometers. So when the car came out of the garage, so its reading at that point of time initially was mentioned on that speedometer 6,000 kilometers. So then the car covered, okay, some distance for the entire day. And then the car came back to the same garage. It is parked in the evening in the same garage. Now that reading speedometer shows 6,500 kilometers. How much is the distance and displacement covered by the car? Guys. When it comes to understand one thing very carefully. When it comes to displacement, we said displacement will be 0. Why, sir? Because the car started its journey from the garage and the car is parked in the same garage. So we say because initial and final point is same. Initial and final point is same. Car starts its journey from the garage and it is parked in the same garage. So that's why we say displacement is 0. But when it comes to the distance, guys, initially the reading was 6,000 kilometers. Initially it was showing 6,000 kilometers. What does that mean? If it is mentioned on the speedometer of the car 6,000 kilometers, means it has previously, before this journey, it has covered 6,000 kilometers previously. So when we talk about this journey, particular journey, we are talking about this one. In this case, it has covered only 500 kilometers. That is 6,500 minus 6,000. Guys, 6,000 kilometers was the distance covered because of the previous journeys. Because of this journey, it has covered only 500. So 6,500 minus 6,000. So that will be 500 kilometers. Guys, is this clear? Please tell me in the chats. Is this clear? Distance covered is only 500 and displacement covered is displacement traveled is, we say, sir, 0. Displacement is 0 and distance is, we say, 60. Displacement is 0 and distance is 500. Is this clear? Tell me in the chats. Everyone means everyone. Is this crystalline clear? Yes. Great. Now guys, see, I think, let me just tell you one more thing over here. Guys, if you want to learn each and every single thing from the scratch with us, every single thing from the detail, okay, and you want to enter the medical college in the 2025, so you want to basically crack NEET 2025, we say we have got a batch that is basically for you. And that is, we say, sir, Phoenix Pro. This Phoenix Pro is, we say, different. Why? See, first and the foremost thing is we will be completing the entire syllabus. And you guys know that when it comes to entire batch, when it comes to each and every single chapter, more than 250 questions we solve in every single chapter in the class itself. Now guys, see. What are the benefits you are going to get in this Phoenix Pro? See, we say access to the special rankers group. Special SRG is basically an online group in which top students of the country are preparing. So you'll be getting the access to that particular batch. And we say exclusive mentorship sessions by educators. Lot of students sometimes face different number of difficulties. At that point of time, they need the mentorship. At that point of time, they need the teacher's guidance, teacher's help. So we say this is for that. Okay, and you have the instant doubt solving in the class itself. And there are other features also, like all India test series. So when it comes to the best of the best test series, so we say you'll be getting in this one, because test series plays an important role in cracking the NEET. If you want the next level test series, we say then this batch is definitely for you. Now guys, let me just tell you, the prices have dropped. If you want to enroll in this particular batch, so it is starting from, and the date is, when it comes to the Phoenix Pro, It is starting from 26 July onwards. So my dear friends, if you want to enroll in this batch, I would request you to join as soon as possible. I would request you to join as soon as possible. Okay, because when it comes to this particular batch, it is just for 5,499 rupees right now. The prices are going to rise, so I would want you guys to join it. Do not miss any of the live classes out there, and the link is in the description below. Most importantly, if you take this subscription, you'll be getting the access to all the batches. Okay, all the batches, whatever is running inside the Unacademy. So join it. The link is in the description of this particular video, and make sure you like this particular session. Smash the like button as soon as possible. And most importantly, guys, see. This was all about the today's lecture. Okay, thank you so much for today. Now I would want you guys to comment down below once I end the live stream. How was the session? I would want you guys to tell me, because I read your comments over there. Okay, so thank you so much. So see you guys in the next session day after tomorrow. So take care and bye-bye. Thank you so much. Thank you so much. Goodbye to all. Do comment in the session. I will be waiting. Thank you so much.